Okay, hello, this is Eric from August Laser. Right now, we are just showing you our TV LGP laser dotting machine. This model is 1.2 meters by 1.9 meters. The host machine will comes with the lithium motor. You can see here. And this one is the blowing system with the electric, so that in case the dust remaining on the sheet when you do the dotting. And in front side there you can see it's connecting with the exhausting system. Okay, now today we just go to introduce the software interface. Right now you can see here is our sign laser point software. It is specialized for the LGP dotting. And on the top side you can see here, this is mainly for the functions items for the mechanical part. For example, like the blow up, blow off is used to control the blowing system, and absorbed on, absorbed off is used to control the work table. So that you can have a like absorption power. So when you put on the sheet, you can be fixed on the work table and not moving. This laser testing advanced setting. Advanced setting is for the professional engineer to do the system, original system settings. So usually you will not need to use that. And for the normal working, we will just concentrate in here. You can see you have three operations, curve, point data. Mainly is concentrating in the three place. About operation is to use to control the process. For example, like this process start, stop, platform, just work table. To move to location, locate position means that when you click it, it will go to original point. To go to original point. Okay, the servo on initialize. It's used to control, to give power to the work table. Forward, back down, left, right. It's used to control the work table. Go inside and come out, and also control the laser head left and right. There you have some signal lines to show you the status. This first page is used to control the laser dotting machine. And for the second page, the curve. Here you will see there have a dislocation curve edit. It used to control set the second line's dots, the dislocation place comparing with the first line. So we can set here the minimum dislocation, maximum dislocation. This dislocation curve is usually to make the dotting patterns more beautiful, but will not affect the result. So it just affect the outlooking of the LGP sheet. Here we have the power range. The power range, we can set the minimum power, the maximum power. If you have more power, the dots will be more bigger. If the power is small, then the dots will be smaller. So in this situation, more power, higher, bigger dots, then the density of the dots will be bigger. Low power, smaller dots, the density will be smaller. So we can use the power to control the density. And here, in this place, the Y1, Y2 is control the Y-axis, the dots, distance changing. Okay? all of the power range and the distance, we have a formula. We have a formula. Different kind of LGP, like one side in LGP or two side in LGP, four side in LGP. They have different formula. When you receive the machine, we will give the formula and tell you how to set it. Okay, so in this page, we mainly control the dislocation curve, power range, y-axis distance. The third page, in the third page, you can see here material-wise and material height. This is used to change your LGP design size. We can type the size here directly. This is a maximum working area. So if your size is 600 by 600, then you can change the numbers 6 by 600 directly. Top margin, bottom margin, left margin, right margin. It depends on you. If you want to have some space on the edge, then you can set the distance. So some customers set it at 5, some customers set it at 3. So it all depends on you. Here the X point, the distance, this is changing. You can set it to change the y-axis, the dots distance. The distance, the numbers smaller means the density is more high. So we can test with it. X speed is the machine engraving running speed. So maximum 4,500 millimeter per second. The frequency you don't need to change, just use the original place. Auxiliary lamps is setting in the software. We also give you the data. So you can just use it directly. It's usually used for the laser head. The acceleration, we need to set some space. So just keep it. Here at the place LGP, if you choose this one, you can create the circle LGP, but most of the time we'll use it for the square LGP. The arrows here, we can choose these rows, columns, you can see here. With these functions, we can put several pieces of the LGP on the work table. And we can change the line. For example, on the rows, if you want to have the 3 pieces, put 3 pieces on the work table, you can just change it to 3. The columns is the same. Row distance, it means for example, if your LGP size is 600 by 600, so the second piece, the row distance will be 600. So it depends on your sheet size. This is a change for the arrow settings. Another thing is for the curve edit. You can see curve edit here. We have this is a power curve lines. We will have showing here bitmap file display here, showing here, just like gray levels. In this picture is typically one side lighting LGP. The place more dark, the laser energy will be higher. Then the density will be higher also. And in the white place, the laser power is lower. And the density will be lower. So in this picture, the light should go through the top side, from top side to the bottom side. Because if we want to get a very uniform LGP, the place which is close to the LED strip should have low density, and the place which is far away from the LED strip should have a high density, so that the far place you can be more bright, and in the place close to LED strip you can let the more light pass through. If the density is too high here, the light will stop here and then will not pass through the next place. Then here will be very dark. So for the LGP adjusting, we need to find the balance. It's not just it's not like if we make as higher density as we can, then the LGP will be better. But we have to find the balanced ways that just this place is not too high, but not too low. We can make sure the light can pass through this area to the edge. That's all. So we need to make a different test and here find the best uniformity, the result, then we will keep it. And here you have see their energy power tables. All of these lampos you can adjust. Each lamp is the represent the power percentage of the laser. So if you find some place is very dark or have no energy, then you can raise that place, the power energy, to increase the dot size. Then the density will be higher. The brightness will be higher also. For this power cave, power changing, you can change in the table directly, and you can also adjusting in the curve directly. Okay, so this is the one side lighting tables. If you use two side lighting, and the top side will be dark. No, sorry. The center side will be dark. The other two side will be white. And you will find that from here, the 100 will change to 0, begins from 0, and in the center will be 100. So that's the different curve, and that's how we adjusting the uniformity. Once you finish that, you can save the file and quit, and then generate data. Then we'll create a LGP file here. And the fourth page is usually for the system settings that will have no relationship with the LGP quality. So you will just need to use it based on our guide. That's the whole functions of the software. And according to just the explanation, the things which can affect the light uniformity, firstly is the power range. Okay, this 11% represent, for example, just now the curve place here. So in this place, minimum power here. In this place, the 0 means the 11% power. 100 means the 31% power. Okay. This will affect the uniformity, and we need to adjust it. And the distance will affect the result also, the density. If your shade size is very big, then we can change a little bigger for the density. And third place to change the uniformity is the curve editing. That's the most important part. And of course, we have the some reference formula for it. And we will give it reference. This one, place. If you want to get the extremely high uniformity, like 90% up, you need to do several testing, find the best power range, best distance, and also the best power curve. Then you will get the different result. Okay, this is Eric from Ox Laser. Thanks for watching.